Hello Steve, today is Monday, May the 12th. And I enjoyed in your last video your attempt to become a true mathematician. But today let me show you how it's done. For everybody out there watching, the question we talked about last time was, the sum of the first three terms of a geometric sequence is 13, and the product is 27. What is a geometric sequence? So to solve this question, we should first look deeper into what a geometric sequence is. It's a sequence of numbers that have a common ratio to each other. So for example, the sequence 1, 3, 9, 27 would be geometric, because each term is multiplied by 3 to get the next one. Now Steve, last time you looked up the general term of a geometric sequence, and it looks something like this. T sub n equals a, r to the exponent of n minus 1, where a represents the first number, r represents the common ratio, n represents the term number, and t sub n represents the term value. So for the example of the geometric sequence 1, 3, 9, 27, a equals 1, because that's the first value. If you looked at those four numbers, the first one is 1. R equals 3, because each next term is multiplied by 3. 1 times 3 is 3, 3 times 3 is 9, 9 times 3 is 27. To give you an example of how the n and the t sub n work, I've given you a couple of examples. When n is equal to 1, t sub 1 is equal to 1. Because n equals 1 refers to the first term number, and t sub 1 equals 1 refers to the first term value. The first value being 1, because that's the first number in the sequence. N equals 2 tells us we're in the second position of the sequence, and t sub 2 equals 3 tells us that 3 is the second number. We can see that t sub 3 is 9 because the third number is 9. In your last video, I came up with the following three equations: t sub 1 plus t sub 2 plus t sub 3 equals 13, and t sub 1 times t sub 2 times t sub 3 equals 27. And this is the perfect first step towards solving the problem. I'm going to take it one step further. This is the first term, t sub 1. It's equal to a r to the exponent of 1 minus 1, which is a r to the exponent of 0, and that's just equal to a, because any number to the exponent of 0 is equal to 1. And if you're not sure about that, you can just check that on your calculator. Next up, t sub 2 is equal to a r to the exponent of 2 minus 1, which is equal to a times r. And finally, the last one, t sub 3 is equal to a r to the 3 minus 1, which is equal to a r to the exponent of 2. If we replace t1, t2, and t3 with a, ar, and ar squared, we get these equations: a plus ar squared equals 13, and a times ar squared equals 27. I'm going to start things off by simplifying my second equation. A times ar squared equals 27. Because it's a times r times a times r times r, that would simplify to a times a, which is a cubed, and r times r, which is r cubed. And a cubed times r cubed equals 27. The next thing I'm going to do is I'm going to take the cubed root of each side. And the reason I'm doing that is I'm just going to try to simplify it and make it look a little bit nicer. The cubed root of 27 is 3, and that's because 3 times 3 times 3 equals 27. The cubed root of a cubed r cubed is ar, and that's because ar times ar times ar would be a times a, which is a cubed, and r times r, which would be r cubed. Therefore, ar equals 3. And to finish off my simplification, I'm going to divide both sides of the equation by r. Because we have two things separated by an equal sign, if we divide both of them by the same amount, say the variable r, they're going to remain to be equal. And a times r divided by r, we'd be taking a number that we don't know, a, multiplying it by another number called r, and then dividing it by that same number. And if we take a number and multiply it by something and divide it by that same thing, we're just going to get the original number we started with back, so a. As an example of that, if we took 2 and multiplied it by 3, we'd get 6. But then if we divide 6 by 3, we get 2 right back. So ar divided by r is a. And on the other side of the equation, we just had 3 divided by r. The next thing I'm going to do is I'm going to substitute that 3 divided by r for a in our original equation, number 1. So for those who don't remember, equation 1 was a plus ar squared equals 13. And now everywhere we're seeing a, I'm going to replace it with a 3 over r. So 3 divided by r plus 3 divided by r times r plus 3 divided by r times r squared equals 13. Next, I'm going to simplify the equations. 3 divided by r remains the same. The next term, 3 divided by r times r, you're dividing by r and multiplying by r, and that's just going to keep the number 3. So 3 divided by r times r is 3. 3 divided by r times r squared, we're dividing by r, but then multiplying by r twice. Therefore, we're going to be left with 3r. So 3 divided by r plus 3r equals 13. The next step comes from a little bit of mathematical intuition. I'm going to multiply both sides of the equation by r. And on the left-hand side, I need to multiply r by each term inside of the brackets. So r times 3 divided by r, and that would be 3. R times 3, and that would be 3r. And r times 3r, and that would be 3r squared. On the right-hand side, we did r times 13, and we just write that as 13r. Just 13r means 13 times r. In the very next step, I subtract 13r from each side of the equation. My goal is to make one side of the equation, the right-hand side, equal to 0, and move everything with the variable onto the left-hand side. So we get 3 plus r squared, and then we're subtracting 13r equals 13r minus 13r. On the right-hand side, 13r minus 13r is equal to 0. And on the left-hand side, I'm just going to rearrange all the terms because it doesn't really matter what order you add or subtract things in. So 3r squared plus 3r minus 13r plus 3 equals 0. And finally, we take the 3r and we subtract 13r. So if we have positive 3r and we take away 13r, that means we're 10 r's in the whole. So we get the equation 3r squared minus 10r plus 3 equals 0. The next step is a little bit tougher because it involves factoring, and you need to know a little bit about factoring. So we're looking for two numbers that multiply to be 9, and 9 came from the first and the last number, 3 and 3. They had to add to the middle number, which is negative 10. And the two numbers that satisfy this are negative 1 and negative 9. So we use the factoring method known as decomposition, where we break the middle term up into two other terms. So 3r squared minus 9r minus r plus 3. We common factor the first two terms, so 3r squared minus 9r, and the last two terms, so negative r plus 3. For the first two terms, the greatest common factor is 3r, and we get 3r times r minus 3. And we can know that for sure is correct because if we expand, we would see that 3r times r would give you 3r squared, and 3r times negative 3 would give us negative 9r. So the first two numbers that we had last time. The second one is the greatest common factor of negative 1. We factor out that negative 1 and we get negative 1 times r minus 3. Next, we common factor out the r minus 3, so we get r minus 3 times 3r minus 1, and that's equal to 0. Next, we make use of something known as the zero principle. So because we have r minus 3 times 3r minus 1 equals 0, we have two numbers that multiply to equal 0. That means either the first one or the last one must be 0. Just two numbers that multiply by 0, one of them would have to be 0. So either r minus 3 is 0 or 3r minus 1 is 0. So for the first one, if r minus 3 is equal to 0, that means that r is equal to 3. And if 3r minus 1 is equal to 0, that means that 3r is equal to 1. And if we divide both sides of the equation by 3, we get that r is equal to 1/3. So if we go back to our other equation, a is equal to 3 divided by r, that means that either a is equal to 3 divided by 3, which is 1, or a is equal to 3 divided by 1/3. So if you're comfortable with fractions, a is equal to 3 divided by 1/3, which is the same as 3 multiplied by 3 over 1, the reciprocal, and that's 9. And if you're not as comfortable with fractions, just throw it into a calculator and see what you get. So to finish it, we have our answers now. But amazingly, there are two answers to this problem. The first answer is a is equal to 1, r is equal to 3. And for a is equal to 1, r is equal to 3, the first term is 1, and the common ratio is 3. So we get 1, 3, 9. And that's the answer you got last time, Steve. But there's a second answer. A is equal to 9, r is equal to 1 over 3. And for that one, the first term is 9, and the common ratio is 1/3. So 9, 3, 1. And those both satisfy the first three terms adding to 13, and the first three terms multiplying to 27. So I hope you enjoyed that little bit of math. It is what I do for a living. And if you have any pointers on how hard or easy that was to follow, let me know so that you always use some input on how well I'm teaching things. So a couple updates and some things before we wrap up. Unfortunately, I didn't get a chance to cook any new meals this weekend. I didn't get as much running as I also wanted to get in, but I did run an additional 2.5 miles, and that puts my total up to 57.5. And to finish on to Battleship, my next shot is I-7, and your previous shot was, amazingly, a hit. I really need to get a hit soon because right now you're completely destroying me in this game. So that's it for now. I really hope you enjoyed my mathematical proof. Or at a very minimum, were at least able to follow it.